Yeah, hi everyone and welcome to the latest soldering tutorial. As always, thanks for tuning in, supporting my channel. Now, I've had a few people asked me recently if I could just put together a total video all about my hot air rework station, how I use it, temperatures I use, protecting parts, etc. So that's the one I've decided to put up next. Now, this is the model I use, a quick 861DA model. Now this version comes with 3 straight nozzles, as you can see on the screen. You can also get a DW version that comes with angled nozzles. Either of them is going to do you a good turn. There's a lot of different branded rework stations on the market. This one retails about £300, but you can get a lot cheaper ones. But yeah, if you do a lot of rework, a lot of soldering, any station is going to do you a great turn. So yeah, get yourself a station and it's going to be invaluable to you. Now throughout the video I'll put together a few demos. I'll show you how to protect your parts, what tapes to use, etc, different temperatures. So yeah, I hope you enjoy the video. And what we do, yeah, this one just quickly, it's got 3 different channels you can store your temperatures in. I think the temperature range on this is about 500 degrees it goes up to, and the airflow can basically be down from nothing to really powerful. So yeah, it's a great station. So what we do, we move on straight away with first demos. Hope you enjoyed the video and learned something from it, and yeah, let's move straight on. Right, so quickly moving on from the introduction to the hot air station that I use, I'm going to come to the 2 tapes that I generally use when I'm using hot air. Now I've got aluminium foil sticky back tape. There's 2 different makes here. You've got the 3M one down the left, and you've got this advanced tapes one on the right. Now the advanced one's about £13 a reel. Now you're going to come to this 3M one, just zoom into the code. Now that one retails for around about £90, so I actually prefer the advanced one. A lot cheaper, slightly sort of thinner, easier to work with, does just as good a job, so that's the one I'd go for. I think it's about 55 metres on a reel, but it's, like I say, it's about £13, really good tape. Now I see a lot of people still using Captain tape when they're trying to protect parts near to where they're working. I find the heat can go through Captain tape and still sort of melt your parts underneath the tape. Some resistors, etc, can lift away. So whenever I'm using hot air, I generally would use the aluminium foil. You get much better protection, reflects the heat much better. So that's what I'd always use. So I'll show you a couple of demos throughout the video of these 2 in action to see what one's actually better. I'll do a quick test later just to prove the foil tape's better. So yeah, they're the ones I'd go for. So go for the advanced one, you can't go far wrong. So anyway, we're going to move on to the first demonstration. I'm going to just show you, I'm going to do a quick demo actually, showing both of these in action on the same device, just to sort of show you what one works better. So we'll move on to that now. Right, so for this part of the video, what I'm going to do, this is where I'm just going to show you the difference between your aluminium foil tape and the Captain tape. So I've got U33, the IC in the centre. I've got these 2 connectors either side. Now they're equally spaced away from the IC. Each gap's pretty even. So I'm going to wrap one of them in aluminium foil tape and the other one in Captain tape. So I'm just going to protect it around the sides over the top. So then we're going to remove U33 using a hot air gun, and then we're going to see the difference in results to see if there's any damage to either connector, to see what tape gives the best protection. So what we do, we'll get these taped up and then we start removing U33. Right, so the first connector we're going to get taped up, we're going to do this one up this end with Captain tape. Now you can get different qualities of Captain tape. Now I don't ever fiddle the tests that I show on my videos. This is actually a good quality Captain, bought from a recognised supplier. So what you want to do here, get it right down to board level so the heat can't travel underneath. So I'm going to put that right down to board level. Get that pushed around the front, and just wrap it around the ends. And we just get the top just pushed down. So that is totally covered with Captain tape. Now you could put another 1 or 2 layers on top. But I'm going to do the same on the other connector. I'm just going to put 1 layer of foil, so I'm not sort of cheating on any of the connectors. So as you can see, I've got it right down to board level, right around the ends, totally over the top. And that's basically covered that connector there. So what we're going to do now, we'll come to this one at this end and we'll get that covered in the foil tape. Right, so come on to the second connector now. As with the previous connector, as you can see, got no damage at all, so it's a fair test. So basically I've got one layer of tape again, as in with the Captain where you just use one layer. So this is the aluminium foil. So again, you want to get it right down to the base of the connector if you can. Just place it right along the base, around the ends of the connector. Let's just wrap that end round as well. And with the foil, I tend to just tweak the top over slightly. I don't always push it right down the connector, so that's going to do a good job just like that. So I've got it right down to the base, right around both ends nicely. So as you can see, both connectors nicely securely taped up. So what we do now, we'll start heating up U33, and then we'll take the tapes off and see what sort of results we got. So let's start taking U33 off now. Right, so now we've got both connectors taped up, we're going to start the removal of this U33 IC. So I'm going to apply the heat generally around the area. I'm going to apply equal heat up both ends, so both of these connectors are going to get similar heat going to them, and then we're going to take the tapes off and see the results. So anyway, I've got my hot air station set to about 380 degrees Celsius. I've got the air on it at 90. It's the quick 861 DA station. So yeah, let's start the removal. So you will hear the air noise as we go through, so hopefully you can hear me over the top of that. So I've already added some rework flux just up both sides of the device just to aid the removal. So I'm basically going to apply the heat equally, so there won't be any favouritism towards either connector. When you take the device off like this, just want to circle the area to give the general whole area some sort of local heat, and then towards the end just concentrate on the device you're taking off. And never try and take the device off too early. Just make sure all the joints are melted. A quick try. No, so just keep going. It shouldn't be too long before the joints are melted. I'm starting to see it go now. With lead free this, that will take slightly longer. So just keep trying the device and make sure it's all melted through. Right, it's starting to go now, I can see it, it's one too long. There's a couple of joints holding it on. It's starting to go. Right, let's get the device off. Just get the tapes off and see the results. Well, first of all, we'll take the Captain tape off. And as you can see, got quite a bit of distortion around here. Just try and zoom into that. You're starting to see quite a bit of change around this area, quite rough there, started to melt. So that's the trouble with the Captain, you will get distorted surfaces, and it, obviously you can melt the plastic a bit more than that. So that's basically what the Captain's done. So let's spin the board around quickly and we'll get the foil removed. Let's just get this turned round, hopefully I can focus in on the foil and get that peeled off. Let's try and get that slightly Right, I'll just get the foil off and then we'll move the camera into position. Let's get that taken off. Let's get that peeled off. As you can see with that side, I know it's a different side of the connector, but you have no damage there at all, and that is what the foil can give you, 100% protection. So yeah, hopefully that's sort of proved the point. Always use the aluminium foil instead of the Captain if you can. Right, so moving on now, come to this 100 pin QFP quad flat pack. Now around the outside of this component there's not too many other components close by, but I still generally protect the surrounding area just so some of them components don't melt and sort of blow away or shift. So basically I've already prepared for this is the advanced tape again, so it's slightly easier to work with I find than the 3M version. So all I'm going to do is place that around the outside. Just want to keep a small gap between the tape and the pins, just to allow the heat to get totally around the pins. Just go around all the other sides, get them done. So you just try and keep a small gap around there. As long as you cover the components, that's all you're generally looking for. Just quickly do the other two sides. So if you're worried about the tape not being thick enough or protective enough, you can always double layer it so it ends up like the 3M tape. So I find this one much more flexible than the 3M one, so this is what I like to go for. Very sticky, it will do you a great job. So as you can see, I've got a slight gap all four sides, and that's what you're looking for. So the heat's going to get perfectly to the pins, and that's basically how I do my preparation. Now I'm ready to start removing this. So now we've protected the surrounding area, ready to start the removal of the quad flat pack. Now I've added some Rework flux around all four sides, probably what you can see just laying on the tape up there. So yeah, basically this is just going to aid the solder to flow nicely. So I've got my hot air station set to about 370 degrees Celsius, got the air still on 90. I've just lowered it very slightly, the temperature, because this is actually a leaded jointed component, whereas the other one was lead free. So what we do is start the removal process. Now you will hear the air as we go through again, hopefully you can hear me above that. So yeah, let's get on with the removal. So again, as I said earlier, just be patient. It will take a fair while, because you've got 100 pins on this device, I believe. So let's start circling the area. I'll change the angle of the nozzle soon. I'll bring it around the other side, just so it's going to aid me to get all four sides nicely heated up at the same temperature. So just circle the area. You've got to be patient when you're doing these type of devices. If you're patient, take your time, you generally will get good results. Let's just bring it around the other side. So just circle the whole area. Just want to get the complete IC and even temperature. I'm going to try the first removal now. Maybe it'll still be a little bit early, but let's give it a go. Yeah, there you go, straight off. Let's try and lift that off. So that come off quite easy. So as you can see, all the pads are intact. That's just burnt flux underneath, you can see there. As you can see, it's just liquid flux that's run underneath. So I've got no damage at all to any of the pins, any of the pads. So that's how easy it is. Now what we're going to do, so quickly remove the foil and have a look at the components underneath. Let's try and peel these off. So you've got 3 capacitors there, perfectly still intact. Let's take this next one off. You've got resistors, small SOT there, perfect again. All the components on that side look good. Now let's take the last one off. So as you can see, every component in the whole surrounding area is still in perfect condition, perfectly soldered to the board. Now, again, like I say, that is just flux, as you can see. So yeah, if you basically, what I've seen with these, where people put captain tape around the area, I've seen people, well, it's even happened to me, when you lift the captain off, some of them components you can see around the edge of the quad flat pack do come away with the captain sometimes. That's why with the foil, just think it gives it better protection, as we saw earlier in the other test. So anyway, what I want to do now, I'm just going to move on to a quick point that I feel is quite important. It's caught me out in the past, so I'm going to just move on to that now. Touch on a point I feel is worth talking about briefly. Now, if you're working on a component quite near the edge of the board, so if you was removing this L1, not only would I protect these capacitors going around the back and the side of the device with the foil, I'd also protect the edge of the board, because I don't know if you can see, but you've got a darker green area up here, and this board's got about 1mm border running right around the outside. If you hold it up to the light, you tend to see that. Just means there's no copper in that area, so it's quite a delicate part of the board. I have seen where the edge of the boards can get quite singed, or even the layers can start splitting. So yeah, what I'll do again, so I'd like to protect these with the foil tape. Quite simple, just lay it on around alongside the component you're working on, just tuck it down the side, and that's going to give you good protection from any damage to the edge. So yeah, like I say, anywhere around the edge, use the foil if you can, and should be good to go. So I'm going to finish the foil demos here. So if you was doing BGAs, I'd just go around the edge of them like I did in the QFN, just to cover the components surrounding them. I've got quite a few foil removals on my other videos on my channel, so I won't show too many in this video. So yeah. Right, so moving on now to solder paste. Now it's got another good use for the hot air gun. So when I get my solder paste, if it comes in a tub, I'll always decant some into a syringe with a small plastic nozzle on the end. So when I'm doing resistors or similar components, I just put a small amount in each pad. Don't need too much. You can always add some or take some away with the end of a pair of tweezers after. Try and get a small amount on each. About the right amount, don't want too much. Right, let's get them laid in position. I always try and keep the writing the same way, it's just easier to read them if you've got a problem. So they're central, so let's get that flowed. Now, hot air station set to about 380 degrees Celsius, these are lead free. Depending on the makeup of your board, if you've got a lot of copper around, you may need it hotter or even a bit cooler. So yeah, let's see how they go. Just circle the area. I'll come in from 2 directions here. I'll bring the nozzle around the other end in a minute. So I just don't want to block the view of the components so you don't you can see what's going on. Let's try and do it from this way, see how it goes. So I don't want to cover the components with a nozzle. Go back to this way. Right, it shouldn't be too long and they'll start going. That one's going at the bottom. That top right hand corner one will take longer, it's got that track coming out of it, thicker track. That bottom left one, then I'll take the nozzle around the other end. So top one's gone nicely. Right, let's concentrate on this bottom one now. There you go, it's found its location, they float into position, and yeah, all 4 joints are gone. So that's all you're looking for. I always find when you're doing pasting, it's slightly harder to get the amount you need rather than when you're soldering it with an iron, but you'll always get a decent result, decent connection, and that's all you've got to do. So I'm going to now move on to an SO8 and we'll do that one. Right, so moving on to resistors, just quickly going to do one more quick demonstration with a paste. Just going to do this SO8 IC now. We've got pin 1 down here, so when you place a component, always check the polarity. Now with this sort of device, what I do, again I've got the paste in the syringe, just a small bead down the centre. Don't need too much. If you put too much paste, you'll probably get some short circuits. So hopefully I can get the right amount here to avoid that. That's about right. So let's get the component placed in position. Always check, like I say, always check your polarity. Just try and get that placed central. And let's get the paste melted now. Hot air station on this one got to about 390 degrees Celsius. This is lead free. Got the air fairly low. If you're worried about the components or surrounding area, plastic connectors for example, like I showed earlier, put some aluminium foil around them, but should be alright here. Don't think this one's going to take too long. So let's get heating this up and see the results. I just circle the area, trying to do both sides. This one should go fairly quick. If your board's got lots and lots of copper in it, sucking the heat away, it could take a lot longer, but I feel like this one will go quick. Quite a simple board this. There you go, you can really see it going. You just keep moving side to side, and that's all going to go. So it's just the M1 up there. Just back to this side, it's all starting to go nicely now. It looks like it's all gone. So that's all 8 pins, nicely soldered. That's what you're looking for. So basically, yeah, it's not too difficult. Say if you've got a quad flat pack, QFN, just go around all 4 sides, similar way, just put your paste along the pads. You might get the odd short circuit, but you can just drag that out with a soldering iron. So that's what you're looking for. Nice components, nice and central. All the pins nicely soldered, and yeah, that's a good result. So anyway, that's all I'm going to show with the paste. Like I say, if you're doing 4-sided ICs, just very similar method to this. Just go around them with a syringe. Try not to get too much on, and should be alright. Like I say, if you get any shorts, just get your iron in there and drag the shorts out. So what we're going to do now, just going to move on to the next subject, and yeah, hopefully that goes alright. Towards the end of the video now, just a couple more points just want to try and get across. Now in this clip, I'm just going to take this IC off down the front, but I want you to keep an eye on the tantalum capacitor behind it. Now I'm not going to put any protection between the two, and yeah, I just want you to see what happens to the tantalum as we take the IC off. So I've got the station set to about 380 degrees Celsius again. It's quite a simple board this, not much copper around the area. If you've got a lot of copper planes around the area, you may have to up the temperature to even over 400. It's really hard to give a general temperature guide out because every situation is different. So anyway, let's start taking this off and see what happens to the tantalum. I'll try and keep the nozzle out of the way, so hopefully you can see what's happening. I'll just circle the area. As always, be patient. Right, it's got the device off. Now, as you can see, the tantalum's taken quite a bit of burning around the device, started to brown up all around it. They don't like too much heat, so if you're ever working, if you look at the one behind it, it's hard to try and focus into that maybe. Yeah, it's quite hard to get in there. But as you can see on that, you've got quite bad browning right around the front side. That's what can happen. They can even go a lot worse than that. If you've got a harder IC to take off, or you need the heat on there for a lot longer, your tantalum is going to take a bit of a battering. So yeah, if you're working anywhere near them, protect them with a foil, should be alright. So move on now to the final clip I'm just going to show in this video. Just want to get this one final point across. This is something that's happened to me a few times over the years. Now I've got a short circuit between these two pins. One of them's going to one end of the capacitor. This pin, this end, is going to this end of the capacitor. Now the problem with that one, it's connected to this large plane going right around here. So trying to separate them just with an iron tip is quite difficult. You're going to need a lot of heat. To get a large tip in there might also not work. Sometimes difficult to get large tips in certain areas, and even the heat from that might not be enough to do this. Now some people would put this on a hot plate to pre-warm the board to maybe 150 degrees. But what I'll do here, I'm going to use a hot air gun as kind of a localized hot plate. But what I'm going to first try and do is just separate these with just an iron. I've got a small conical tip. Like I say, you can try a large tip, but even that's difficult. So I'm just going to add a small amount of Rework flux across the front of the area. Now it's a lead-free board, which certainly doesn't help. It's going to take a lot more heat to get that separated. If you just go in with your iron, that is just going to make the matter worse. All that's done is add more solder to it. So that's what generally happens if you're going with this is a small conical, but a large iron tip can do the same thing. So all I'll do here, get me hot air gun, got it set to about 250 degrees, which isn't enough to melt the surrounding components. So I'm just going to apply that heat to that area, and then go in with the iron after and see the results after that. So just give it a good blast of the heat. It's going to take a short while to get the heat into the area. And just hold it on for a fair while. It's not going to melt any of the other pins or the two capacitors at the front of the IC. You can also hold the air in one hand if you're quite dexterous, and go in with the iron in the other hand. But I'm going to go straight in with the iron and see the results I get. See the flux bubbling away. I'm going to try that at this stage and see if we've got enough heat generated so far. Right, so I'm going to go straight in with the iron tip and see if that can drag that away. See, it certainly fairly good result. Just going to give it one more go. I reckon I'll get that out next time. What I'm going to do here, I'm going to keep the heat applied to it and then try it again with the iron. Let's try it straight with the iron now. There's a lot of solder to try and drag out of there. Just separated it. Just try and get that other joint in nice shape. There you go. Got a nice result there. So if you find it doesn't work the first way I tried, keep your heat applied to it and then go back in with the iron as well, and eventually you'll get a nice result like this. Now I'm just cleaning this with Ultrasol cleaning fluid. I've done a video totally dedicated to cleaning, how I clean my boards. As you can see, I've got a nice separated pair of pins. So I've got a nice clean result in there now. Try and zoom into that slightly. go out of focus slightly. Try and get the focus back in. But yeah, so you can see I've got two nice joints, nicely separated, and that is a way of clearing tricky shorts. Like I say, going with the iron first. If that's not enough, just go in then with the hot air and the iron, and you will get this result. Like I say, if you haven't got a hot plate, try it this way. And the hot gun I actually find sometimes a better method. It's just a localized heat source. And yeah, this is a really good way of getting really tricky ground pins a nice shape on your solder joint. And yeah, so hopefully you've learned something from that method. So anyway, right, so I've just quickly removed the rest of the Rework flux. So this capacitor at the front here, the pins going up to either end of that. Now as one of them is on that large plane, as I explained earlier, it's going to make repairs like this quite difficult, but as we've shown, it can be done. So as you saw, going in with a soldering iron generally probably won't work when you've got a large plane like that. Method 2, where we applied the heat and then went in with the iron, still didn't work in this situation. But method 3 is often the one that will work, where you hold the hot air over the joint at the same time as going in with your soldering iron. So you've got a double blast of heat, and that's the one that generally gets me out of trouble, and I think it can help you hopefully a fair bit in the future. So yeah, anyway, that's that point. So going back to hot air stations quickly, a lot of good people on YouTube recommending and reviewing them on other channels. So yeah, check some of them out and you'll find one that suits your needs. Going back to the foil tape also, just get one that's adhesive lined. That's the important thing. You don't need to spend too much money. Like one I use, like I said earlier, is not too dear. So yeah, just pick one of them up and you should be good to go. So anyone who's just using Captain tape, please try the aluminium foil. Just for a trial, see how you get on with it, and it'd be good to hear your comments. So yeah, until what we do, I'm just going to put a few more photos up now, and I'll return in the near future with some more soldering videos. So until then, thanks for your time and support. Enjoy your soldering and take care.